Here I've got a pattern of shapes. Got one square here. Got 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. And then what I want to do is draw the next pattern. So we've got the first one, second one, third one, fourth one. I want the fifth one. You can see the fifth one will have 9 squares. Right, it'll have 9 squares. How do I know that? Because if you look from term to term, if you look at each of these terms, to get from 1 to a 3, you add 2. To get 3 to a 5, you add 2. 5 to a 7, add 2. 7 add 2 will give you 9. So it looks like these are going up in steps of 2. We're adding 2 each time. So 7 add 2 makes 9. So the next one will have 9 squares. I mean, it's no good just doing 9 squares along here like this. That wouldn't follow the pattern. So you can see here, to follow this pattern, we've got 1 square here, 2, 3, 4. So there's 4 on the bottom of this L shape. 4 over here, so the next one will be 5. Right, I've run out of space over here, so I'll do it over here. Check. 1, 2, 3, 4, 5. And then you can see here, just zoom out a bit. Right, you can see we've got 1 square, 2 squares, 3 squares. It'll be 4 squares. 1, 2, 3, 4. Right. So look, have a look again. 1 square, 2, 3, and then 4. And then this way, got 1, 2, 3, 4, 5. And then to double check, we should have 9 squares. So fifth one, this fifth one here should have 9 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go. That's the fifth pattern as required. Now, because these are going up in equal steps, we're adding on 2 each time. This is what you call a linear sequence. Right. So if they're going up in equal steps, for example, it could be add 5, add 5, add 5, add 5, the linear sequence. It could be add 100, add 100, add 100, linear sequence. And it just doesn't have to be adding, it could be takeaway as well. Here's an example. Let's say I start off with 12, I got 9, 6. So what's happening each time? It looks like it's going down in steps of 3. 12 take away 3 is 9, 9 take away 3 is 6, 6 take away 3 is 3, 3 take away 3 is 0. And you can carry on that way as well. 0 take away 3 is minus 3, take away 3 minus 6, and so on. It's a linear sequence of numbers because these are going down in equal steps. So remember, whenever you're adding or taking away in equal steps, then it's a linear sequence. There's another way of getting the fifth one, the fifth pattern. All you got to do is copy. If you can get this one, just copy this one, copy the last one that they're giving you. So if I was to copy that, do it here, just copy that one. So as it stands, first, second, third, fourth, that's the fourth one. I've just copied the fourth one. So to get the fifth one, all I'm going to do is, remember, I'm adding on 2. So add on 1 on this side, 1 on the other side. And you can see that's how this pattern is growing. Right? So that would be the fifth one. So to get the next one, I'd have to copy that one and add on 2 more. Right. So what would not be a linear sequence? What would be a non-linear sequence? a nonlinear sequence wouldn't be going up or down in equal steps. Here's an example. Right, you might think, okay, it's adding 4, but here it's adding a lot more, and it's adding a lot more. So it's non-linear. It's not going up in equal steps. And it looks like 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54, and so on. You might argue to say, oh, look, same number. It's the same number. So therefore, it's a linear sequence, but wrong. Remember again, linear sequence is when numbers are, when you're adding or taking away the same number over and over again. Whereas here we're timesing. So this is non-linear. Another example of a non-linear sequence would be, for example, right, so what's happening here? I'm adding 2, 4 add 2 is 6, 6 add 4 is 10, 10 add 6, 16, 16 add what? You got 2, 4, 6, so add 2, add 4, add 6, looks like the 2 times table, add 8, 16 and 8, 24, and so on. So you can see a pattern here, add 2, 4, 6, 8, add 10, add 12. These are not going up in equal steps, so it's non-linear. Right, once again, those numbers that I had over here, remember 1, 3, 5, 7, we said this is a linear sequence because we're adding the same number over and over again. Here they are again. First term, 3, second term, third, fourth, fifth term. So if I was to plot these as coordinates along here, so if I plotted this as 1 along the corridor, 3 up the stairs, 1 along the corridor, 3 up the stairs, next one, 2 along the corridor, 5 up the stairs, 2, 5, next one, 3 along the corridor, 7 up the stairs, 3 and 7. Right, I've run out of space for the others, but you notice if I was to join these coordinates, it makes a straight line. It makes a straight line, linear. Okay, line, linear, straight line. This is why it's a linear sequence of numbers. Whereas this one, for example, is not a linear sequence. Look. 1 on the corridor, 1 up the stairs. 1, 1. 2 along the corridor, 2 up the stairs. 3 and 4. 3 and 4. 4 and 7. 4 along the corridor, 7 up the stairs. As you can see, this is not a straight line. It's more like a curve here. That's why it's non-linear. So these numbers that I have here are actually non-linear. They're not going up in equal steps. And same for these. These numbers are not going up in equal steps, even though I'm timesing by the same number over and over again. One thing I want to show you very quickly is, I want to